Good morning everyone, myself Shivokeshwani and today I am here to teach you science. Basically in science today we will be learning about atom and its structure which is the topic of class 9th. So our first topic of under this chapter is atomic number which is represented by capital Z. You can say it is a symbol of atomic number used for denoting atomic number. Okay, now the proper definition is that it is not the proper definition, just for understanding I have written it. It is a kind of ID card. Why ID card? Because it gives us all the information related to an element, and if you are going to change that element's atomic number, that means you are going to change the element itself. So this much important atomic number is. Fine. Now the proper definition which is mentioned in your book is the total number of protons. We will proceed with a definition, don't worry, but for those who don't know, let me explain what is proton. You know that it is somewhere looking like structure of an atom. I am not very sure with this, but something like this. Now here these orbits or shells, here electrons are present. Electron. Now in this hard dense central core, pro what is present here? Proton and neutron are what these are present here. Fine. So for those who don't know what is this diagram and all, see, it is the structure of an atom. Atom is the smallest part of an element or a compound. It also has three parts. Those are electron, proton and neutron. So here I was depicting their structure only, how are they arranged and all, like this. Here proton and neutron are present and electrons orbit are present in this and shells or orbit, and these shells are called energy shells. About this only you are going to learn in this chapter. Fine, understood. They are positively charged particles. Neutron, they do not carry any charge, and electrons are negatively charged particles. Fine. Now symbol, as we talked about the symbol of atomic number, it is represented by capital Z. By capital Z. Fine. Identity. How can you identify atomic number? See, an atomic number is a kind of unique identity of an atom. You know what is atom? See, atomic number is a kind of unique identity of an atom. If you change the atomic number, you change the element itself. I told you about this. I think I explained you this thing, that if you change the atomic number, you change the element itself. So this is the importance of atomic number. Fine. Now our next topic is neutral atom. What is the next topic? It is neutral atom. In a neutral atom, now what is neutral atom? The number of proton, you know what are protons, is always equal to number of electrons. In, if we see normal kind of atoms and all, so their number of proton and electron is not equal, but neutral atom are special kind of atom. Here number of proton is equal to the number of electron. Fine. Point to be noted or point to be remembered. Now our next topic is atomic number. Atomic number we have discussed, but now we are going to talk about atomic number in neutral atom. Atomic number in neutral atom. Okay, here simply it means the number of proton is equal to number of electron. Fine. Now the main major topic which we are going to start today is Bohr-Bari scheme, which is you can say it explains that how are electron distributed, Okay, and it also explains us how are electron arranged in different shells or orbit. Fine. This section explains us how electrons are arranged. See, definition we will read, but before we actually read the definition, I want to demonstrate you something. See, again I'm going to draw that diagram only. Here it says how electrons are arranged in different shells. First of all, what are shells? What are shells? These you can see, these circle like structures, they are only called shells, orbits, or energy shells. Where are electrons present? Electrons are present here, 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 here. Fine. So this section explains us how electrons are arranged in different shells around nucleus. Where is nucleus? Nucleus is here, this central core. Inside nucleus, which two parts are present? Proton and neutron. Fine. So this whole diagram you need to remember. Here it is not that much clear, but in your books it is given very clearly in a detailed manner. Please go through that diagram very carefully, because if you will once understand the diagram, this chapter is nothing as such rocket science. Okay, so let's continue with the definition. This section explains us how electrons are arranged in different shells or orbits around nucleus. You can simply write this section explains us the arrangement or distribution of electrons around different energy shells and nucleus. Fine. Now there are some sort of rules in Bohr-Bari scheme. First is 2n square formula. What is this 2n square formula? Where it can be used? See, the maximum number of electrons that can be accommodated. Accommodated means can be arranged. Here it means can be arranged, but if you see it generally, it means giving shelter to someone or keeping someone at home, like this. Fine. So the maximum number of electrons that can be accommodated or arranged in a particular shell is calculated using this formula, which is 2n square. What is this n? N is the shell number or orbit number, and if each shell has its different shell number or orbit number. Let's see. K shell. K shell's shell number or orbit number is 1. L shell. L shell's shell number is 2. M shells shell number is 3, and N shells shell number is 4. So if you need to find out the maximum number of electron that can be accommodated in K shell, then it will be 2 times n square. Here the value of n is 1, so 1 square. For L shell it will be 2 times 2 square. The value of n here is 2. M shell it will be 2 into 3 square. The value of n here is 3. N shell 2 into 4 square. The value of n here is 4. Fine. Like this you can find out the maximum number of electron that can be accommodated in particular shell or orbit. Rule 2 is outermost shell limit. Outermost shell I don't know, but here I am drawing. If we see this diagram, then outermost shell is this. Fine. Now the outermost shell can not hold more than 8 electron, means its capacity for holding electron maximum it can hold 8 electron, not more than. Even if it is theoretical capacity. Theoretical capacity means its capacity of holding electron. Okay, even if it is its theoretical capacity is higher, like M shell, not M shell. M shells is also second higher. N shells is the highest. It is 4. Yes. Second to last. This one is the last one. This one. Now we are talking about this. The second to last, which is penultimate shell, cannot hold more than 18 electron. Fine. Example: calcium's atomic number is 20. Fine. Understood? Here they have given the chronological order also. Inside 1 2, outside of that 8, then again 8, then 2. Incorrect one is 2 8 10. Why 10? because the outermost shell cannot have 10, it can only have up to 8. Fine. Our rule 3 is stepwise filling. The outermost shell cannot hold more than something, some typing errors are there. The outermost shell cannot hold more than 18 electron. And a penultimate shell cannot hold more than 18 electron. Fine. this this one is the correct one. There was some typing error, I don't know. Unless the preceding inner shell is completely filled. Fine. According to 2n square rule. According to which rule? 2n square rule, which is the first rule. Fine. Now, the next topic is timeline. Timeline, you will might think what timeline, because in your NCERT separately, I think it is not given. It is given on different page. So for you, I have arranged it in chronological order. Chronological means first which thing happened, second, third, like this. So here it tells us in which year the scientist did what discovery related to atomic theories. Fine. First name is of John Dalton, around 1808. He proposed atoms are indivisible fundamental unit of matter. Indivisible fundamental means basic unit of matter. Fine. Goldstein in 1886 discovered protons via canal rays, means protons also and canal rays. Thomson around 1897 discovered electrons using cathode rays, proposed the plum pudding model. Also remember the name of this model, maybe it can come in your exam, a MCQ or one word answer like this. Rutherford around 1911 he proposed gold foil experiment which led to the discovery of nucleus. Nucleus is the hard dense central core inside which proton and neutron are present. Fine. Proposed a nuclear model as well. Fine. Bohr-Bareiss scheme you learned right now. Electrons revolve in discrete orbits. You read right now. Introduced energy levels and stability. Now Bohr-Bareiss you read it combined in a combined form, but no, they are separate. Here you will read expanded Bohr's work. He expanded Bohr's work. That's why we call it Bohr-Bareiss scheme. Bohr-Bareiss is not name of, it is not the name of one person. Expanded Bohr's work by providing rules for electron distribution in shell. That's why it was written Bohr-Bareiss scheme. Fine. Here Bohr's theory were also included and Bareiss' theory were also included. Around 1921, Chadwick discovered neutrons, completing the modern atomic model. Fine. Everything was discovered, neutron was left. So he completed this work also. He discovered neutron, which led to the completion of model atomic theory. Fine. Now one question is there for you, which might have 2-3 answers. Why do atoms combine? First one is the octet rule. What does it state? Let's see. It states that atoms combine to attain a noble or inert gas electronic configuration. See, it is not that tough. It also simply means the arrangement of arrangement of electrons. Okay, with that it also describes their position. Okay, and where are they present, and also you can simply mean that it tells us the position or how are electrons arranged in different shells. This is the new term you can say. If you know, then it is nice, but if you don't know, then it is not something else. It simply means how are electrons arranged in different shells. So atoms combine to attain a noble or inert gas electronic configuration. Find goal. What is their goal? Their goal is to complete their octet, means 8 electron in the outermost shell, or a duplet of 2 for helium. Fine. Method. How do they perform this? Atoms do this by forming chemical bonds through sharing, losing or gaining electron. Means how do they perform this? How do they complete their octet? 8 electron in the outermost shell and a duplet for 2 for helium. See, atoms do this by forming chemical bonds. About this you will read in organic or inorganic chemistry. I'm not sure which one. Through sharing, losing or gaining electron. They were share, lose or gain electron. Now there are the top 5 questions which have the chance of 90% to appear in your exam. I won't be discussing the answer, just I would be telling you main points. You have to frame it yourself because I have explained everything. Fine. State 3 main rules of the Bohr-Bury scheme for electron distribution. You know, first one is 2n square rule. Second, the outermost shell cannot hold more than 8 electron, and the second to last penultimate more than 18. Last one was proper filling one. Fine. What is the maximum number of electron that can be accommodated in M shell? Show the calculation. Show the calculation means 2 into, what was the formula? First you will write 2n square. I am not telling you step by 2n square rule. So here everything will be same, just n will change. Now what is the value of n means what is the shell number of M? 3 square. So first you will solve this one, exponent 1, 2 into, if you will multiply 3 2 times, what will be the answer? 9, 18. This will be your answer. Fine. Define valency. Whatever questions are related to valency, we are leaving that because in this part I did not cover up. I have not explained anything about valency. In the next part I would surely. This question is also related to valency, this one also. If you know, very good. If not, you don't know, then wait for part 2. Which experiment led to the discovery of nucleus and who performed it? Here you need to, which experiment and who performed it. So which experiment? The gold foil experiment. Gold foil experiment. By whom? By Rutherford. When they are not asking, but for required information I have told. If you remember, very nice. If you don't remember, 1911. Fine. So from my side I have explained this chapter, not whole, whatever I can teach you maximum in this part 1. Now it's your time to revise. Wait for my part 2. In part 2 I would be covering the leftover topic with valency, and also some practice questions or top 5 questions will be there related to valency as well, and I would try to frame some competency based questions for your practice. Bye. Don't forget to like and subscribe. Take care. Bye. Study well.